Hello student, in the previous lecture we discussed the synthesis of nitrofurantoin. Today we discuss the structures of quinolones derivative like Nalidixic acid, Norfloxacin, Enoxacin, Ciprofloxacin, Ofloxacin, Lomefloxacin, Sparfloxacin, gatifloxacin and Moxifloxacin. So now start. So these all drugs are urinary tract anti-infective agent. The first structure is Nalidixic acid. So the first is Nalidixic acid is 1,8-naphthyridine derivative, and the substitution take place position number first, position number third and position number 7, also position number 4. So the substitution is position number first is ethyl group and position number 4 is carboxylic group, 3 is carboxylic group and position number 4 is oxo and 7 is substituted by methyl group. So this is the structure of Nalidixic acid and approved in 1963. So the ring is nucleus 1,8-naphthyridine having 2 nitrogen atom. So this ring is not a fluoroquinolones derivative. This is the 1,8-naphthyridine derivative having 2 nitrogen. Now the second structure is ciprofloxacin. So first is ciprofloxacin is fluoroquinolones derivative. This is fluorine and this ring is quinolone. So derivative is fluoroquinolone and the fluoroquinolone antibiotic, and the substitution is first position, third, fourth and the 7th position. So the first position is substituted by cyclopropyl group, position number 3rd is substituted by carboxylic group, position number 4 substituted by oxo group, position number 6 substituted by fluorine and the position number 7 substituted by the piperazine derivative. So this is the structure of ciprofloxacin. Now ciprofloxacin used various bacterial infections like bone and joint infection, infra-abdominal infection, diarrhea infection, respiratory tract infection, skin infection, typhoid fever and also UTI infection. So these are the use of ciprofloxacin. Okay, now discuss the third drug is norfloxacin. So norfloxacin also fluoroquinolones derivative and fluoroquinolones antibiotic, and the structure of norfloxacin is the position number 1 is substituted by ethyl group, third is substituted by carboxylic group, position number 4 substituted by oxo group, 6 is substituted by fluorine and 7th is substituted by the piperazine derivative, piperazine, not derivative, and fluoroquinolone antibiotic. Norfloxacin antibacterial and its mode of action depend on blocking of bacterial DNA replication by binding itself and to an enzyme called DNase gyrase. So it shows the binding of the DNase gyrase enzyme and the mechanism of action is a bactericidal and derivative is fluoroquinolones antibiotic. Now move into the next drug. The next drug is ofloxacin. So ofloxacin contain oxygen ring. This is the oxygen ring linking the nitrogen at position first. This is the position first of nitrogen and this is the carbon of position number 8. So this oxygen ring linked with the position number first and the position number 8, and the derivative is fluoroquinolones derivative and the nucleus is fluoroquinolones. Structure and the side chain and the substitution is position number 3rd is carboxylic group, position number 4 is oxo group, Position number 6 substituted by fluorine, and position number 7 is substituted by piperazine, and substitution in position number 4 of piperazine with methyl group. So this is the structure of ofloxacin. So ofloxacin का use to treat certain infection including pneumonia, infection of the skin, bladder, and the reproductive organ and prostate. These are the use of ofloxacin, and the action is bactericidal. Not work for cold, flu, or other virus infection. So these drugs are not effective in case of cold, flu, and virus infection. Now moving to the next drug is sparfloxacin. So the basic nucleus is sparfloxacin is also fluoroquinolones derivative, and the substitution is first position cyclopropyl, third position carboxylic, fourth position oxo group, and the fifth position, this position in new, is sparfloxacin. Here is the substitution of amine group, and the position number 8 also substituted by fluorine. So here is the 2 fluorine group and substitution of two position of quinones derivative, position number 6 and position number 8, and the position number 7 substituted by the piperazine derivative and piperazine, and in this structure position number 3 and 5 of piperazine substituted by the methyl group. So here is the dimethyl piperazine, and the new is position number 6 or position number 8, both are substituted by fluorine. So here is 2 fluorine group and 2 methyl group. So this is the structure of sparfloxacin. Now fluoroquinolones antibiotic. This is the fluoroquinolone antibiotic. Second, antibacterial activity by inhibiting DNase gyrase enzyme, used to treat respiratory infection, and several side effects of this drug. First is allergic reaction like fever, chills, difficulties in breathing, swelling over your face, lips, and throat. So these are the major side effects of sparfloxacin. So the next structure is gatifloxacin. Gatifloxacin, the basic nucleus is fluoroquinolones derivative, and position number first is substituted by cyclopropyl, position number third is substituted by carboxylic, position 4 is oxo, position number 6 is fluorine, and the seventh position is substituted by piperazine, and this piperazine position number third is substituted by methyl group, and position number 8 substituted by methoxy group. So the structure of ciprofloxacin and gatifloxacin. So difference in the position number 8 is substituted by methoxy group, and position number 3 of piperazine is substituted by the methyl group. So this is the basic difference of the structure of ciprofloxacin and gatifloxacin. So now fluoroquinolones derivative, the first point, and second is bactericidal effect, and this is the fourth generation drug. It works by inhibiting the bacterial enzyme DNA gyrase. So this is also having the bactericidal effect and inhibiting the bacterial enzyme DNA gyrase. Okay, so now drug is enoxacin. So the structure of enoxacin, it is also not a fluoroquinolones derivative, it's a 1,8 naphthyridine derivative, 1 and 8th position. This is in this ring also having 2 nitrogen, and the derivative is 1,8 naphthyridine derivative as a nalidixic acid, and 1,4 dihydro first and fourth position is dihydro 1,8 naphthyridine with an ethyl group at the position number first, and the carboxylic group position number third, oxo group in position number fourth, and the fluorine is position number 6, and this group is similar. Position number 7, the piperazine group. So this is the structure of enoxacin. It is not a fluoroquinolones derivative. It's a 1,8 naphthyridine derivative. So what is the use of this drug? Used for skin treatment, UTI, urethral and endocervical gonorrhea, and the action is bactericidal. Okay, so now move into the next drug is lomifloxacin. So the structure is lomifloxacin. It is a fluoroquinolones derivative, and position number 1 is substituted by ethyl group. Position number 3rd is carboxylic group. 4th is oxo group. 6th position is fluorine group, and the 7th position is piperazine, and piperazine is substituted by 1 methyl group. 1 2 3 4 5 6. Okay, so this is the structure of lomefloxacin. So what is the use of this drug? Used for bronchitis and UTI. Prophylaxis में इसका यूज होता है, UTI prophylaxis में, and it is a broad spectrum antibiotic and the action is bactericidal. So this is the lomefloxacin. Now move into the last drug of the quinolones derivative, moxifloxacin. So this is also fluoroquinolones derivative, and the first position is substituted by cyclopropyl. Third position as similar, substituted by carboxylic group. Fourth position is oxo group. Sixth position by fluorine. But the major difference in the seventh position, this is 2,8 diazo bicyclo 430 nonyl derivative. The numbering starts from the fused position, 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8 and 9. So position number 2 and 8 is substituted by nitro compound. So 2,8 diazo, and ring system is bicyclo, and this is the breeze, and in this side of breeze here is 1 2 3 4 atom, and here is 1 2 and 3 atom, and this breeze having 0. So 430, and the total carbon is 9, so nonyl derivative. So the major difference of moxifloxacin in the 7th position, and the all side chain and all the substitutions are similar. So this is the structure of moxifloxacin. And now this is the bactericidal action against both gram positive and gram negative. Inhibition of the enzyme topoisomerase 2nd and topoisomerase 4th. So this is inhibit the both enzyme topoisomerase 2nd and 4th, and used to treat certain infection like pneumonia, skin infection and abdominal infection. This drug is synthetic and the broad spectrum antibiotic. Okay, thanks for watching.